Hi, I'm Jennifer Musica. I'm a faculty member at Center College in Kentucky. This video was developed for the Active Learning in Organic Chemistry workshop to introduce organic chemistry faculty members to the range of question types that can be used in classes. Probably the first type of question that comes to mind is predicting the products for a reaction. Another question type that can help uncover student misconceptions involves asking about reaction intermediates to see if students understand the mechanism of the reaction. I've used this one in class and students find it challenging. They remember that HBr has different regiochemistry, but they don't remember why. Most clicker systems have a mechanism that enables instructors to ask multiple choice questions. Some also have the ability to ask numerical questions. So if you're using a system that will allow you to ask numerical questions, you don't need to have the multiple choice items here, and students can just answer with a number. My students find Newman projections challenging, and a multiple choice question with different Newman projections pushes the students' limits for their cognitive load. They have a hard time figuring out how many carbons are on these different structures. Students are most comfortable with questions that ask them to predict the products of reactions. Asking questions where they supply the reagents helps them prepare for when they're going to have multiple step synthesis later in the term and in second semester. Questions with multiple chiral centers are really challenging for students. The chiral center labeled 1 is especially difficult since the lowest priority group isn't a hydrogen, and you have to compare the alkyne and the aromatic ring and their priorities. So carbon 1 is S because the phenyl ring is higher priority than the alkyne. Carbon 2 is R because the OH has the highest priority. Clicker systems that allow students to input text can be used to answer questions of this type. Otherwise, the instructor needs to set up the choices for this to be a multiple choice question. Students often forget the relative acidities of phenols and alcohols. Suzanne Reuter and Andre Straumanis have a very nice article in JChemEd about innovative ways to ask interesting organic chemistry questions with clickers. Here's one example from their paper. Notice that this question asks for the best starting materials. Multiple combinations would work here, although some folks wouldn't consider 3,7 to be a Michael reaction since the donor only has one electron withdrawing group. Same thing with 4,5. The best combination of starting materials in this case can use a weaker base since Michael donor 1 has 2 electron withdrawing groups, and then the reaction involves hydrolysis and decarboxylation after the nucleophilic attack. This question is inspired by Reuter and Straumanis. It's one I've actually used with my students. These multiply substituted aromatic compounds can be challenging as students have to consider the directing effects of substituents already on the ring. Here's another one from Straumanis and Reuter getting at mechanistic questions. This clever approach allows instructors to distinguish between SN1 and SN2 reactions. SN1 involves 2 steps, which can be indicated by the 0 between the other numbers. 3, 6, 7, 8, or 7, 8, 3, 6 suggests a concerted reaction where all the bonding changes happen simultaneously. Alison Flynn introduces the idea of retrosynthesis in her 2011 JChemEd article about interesting ways to ask organic chemistry questions with clickers. So she uses a lot of numbers on the structures to make sure students recognize bond disconnections. And here's a really complicated synthetic target with lots of different places to make aldol products. With a target as complex as discodermalide, there's multiple segments of the structure that might be connected using an aldol. Students recognize it's possible to reduce aldehydes and ketones into alcohols and convert alcohols into esters when they identify the various acceptable answers in this question. Sometimes the clicker systems allow for students to identify a part of a structure instead of answering a multiple choice or numerical or text input question. Kevin Shea's JChemEd paper describes his use of learning catalytics to ask questions about charge distribution and resonance stabilized ions. I haven't had a chance to use learning catalytics, but this feature looks very nice as it tells the instructor how many students got the question correct. I think that Top Hat and URespond also provide similar feedback to the faculty member. I appreciate workshops where the presenter makes a word cloud from participant answers. Learning catalytics can provide word clouds from student answers to organic chemistry questions like this one that Kevin Shea asks in his class. So you can see the students want to start this the same way I do, which is substitution to make an alcohol before you oxidize to the aldehyde. This question type was taught to me by Vince Maloney, who's a faculty member at Purdue University, Fort Wayne, and he's a member of the Organickers Leadership Board. He led the clicker sessions at the ALOC workshops for years, and this is one of my favorite approaches. He has students work on this problem in groups for a few minutes, and then he walks around the classroom and copies down the answers that they give and writes them on the board and has people vote on the different possibilities. So he turns it into a clicker question after the students generated the choices. When technology fails me, I have my students use fingers to answer questions. I have colleagues that print up colored sheets of paper that students fold up and use to answer clicker questions in class. I have another colleague that uses the Plickers system, and Plickers is really cool. Students hold the weird shapes in different directions to indicate their answers, and they just keep this card, and the instructor looks at the classroom with their phone, and they can tell who said what and how many answers there are. Otherwise, these are some low-tech options of how to do clickers. Here are the full references for the Flynn, Stramanis, and Shea articles. And here are some other general resources that talk about how to implement clicker questions in active learning classrooms.